Hello, class. I just kind of want to give you guys a quick summary of what we talked about yesterday in class. We said that we are going to hold off on this particular question here, and I believe this was exercise 4-1, I believe so. But we'll hold off on that for now. And let me just take this opportunity to look at other questions before we get to that point. So I'm really addressing this problem here for F41. Okay, so we have this structure here whereby it's on a pin, right, and it has a roller here at this point. Okay, and we have a moment here, and that's 600 pounds foot, right? And let me just come out a little bit more here. This is not okay. Okay, and then we have again this 600 pounds foot, and then we have a force here. Right, that's 500 pounds. And we have a 3-4-5 triangle. 3, 4, 5 triangle. Okay. Okay, so and then we have the different dimensions from here to here to here to here, and this was, I believe, 5 feet apiece. 5 feet, okay. And this is A and this is B. So I always want you to remember that whenever you have, this is a roller, it's being constrained in two ways, X and Y direction. Then you have, I'm sorry, this is a pin. I'm sorry, pin, some people use it as a hinge. Okay, and this is a roller. Okay, and it's restricted only in one way. That could be X or Y. This is X and Y, and this is X or Y. Okay, so in this case, we have a pin here, and we have a roller here at B. Okay, so this is our first step. So we have this force, 500 pounds, right, that's acting at this location 5 feet away from A and 5 feet away from B. So our first step is to draw a free body diagram. And once we do that, you typically see what we have here. Okay, so again, this is a pin, right? It's going to have two, I have here, it has two support reactions, both in X and in Y. And the roller has only one support reaction. Okay, so this is in our X direction, this would be in our Y direction, labeled AY, AX, because this is along the X axis, this is along the Y axis. Okay, so with that in mind, now we have our roller here. Again, is only constrained in only one direction, and it only has one support reaction. In this case, it's going in the positive, going towards the positive Y direction. Okay, so once we resolve our forces, this is in the Y direction, this is in X direction. We resolve that force and we get 400 pounds for the Y, 300 pounds for our X. Okay, so now the next step is to really calculate the support reactions, right, for AY, BY, AX. Okay, so when we do that, we again, in order to do this, to execute this step, you have to use your equilibrium equations. Your equilibrium equations. Some of the moments about any point equals 0. Some of the forces about the x direction equals 0. And then some of the forces in the y direction equals 0. Again, these are what you know as your equilibrium equations. So these are the tools that you'll need at every given time to solve problems. And you can unscramble them. You can use one to solve the other and vice versa. Okay. So our first approach really is, again, these support reactions are nothing more than the forces. Always keep in mind that support reactions are nothing more than forces. Okay. So if you use some of the moments about, if you go about using our moment, right, about point A, which I have here, you have that 500 pounds. Our first force in the y direction, right, is 5 feet away. So you have this expression here. Okay. Then our next force is going to be By, which is 10 feet away. That's right. But now this force By is going to go counterclockwise to my position that I chose in the beginning. That's why you have a negative here. Okay. And our next force, or our next moment, I should say, will be this 600 foot-pounds right at the edge here. And that's what you have here. And it's going clockwise, which is in accordance to what I chose from the beginning. So when you do the math, then you get 200 foot-pounds minus By of 10 plus 600 foot-pounds equals 0. Okay. Then you solve for By. And your By here is 260 pounds. Our next step now is so we found support reaction By. We need to find our support reaction Ay and Ax. So for the Ay, the first step I'll encourage you to do is just take the moments about point B now. Let this be your point of interest now, point B, where the roller is. So some of the moments about point B equals 0. Then of course we have 600 pounds. This is a moment right here, and it's going clockwise. And then when we go moving away from point B, we find a force of 400 pounds here, and that is actually 5 feet away. And this is what you have here. This right here would be, so this would be 400 times 5, okay, which gives us 2,000 here. And then our Ay, A sub y is 10 feet away, right, from, it's a force that we don't know that we want to calculate, and it's 10 feet away from By, okay, and that's what you have here, and that's going to be in a clockwise position. You do the math, you get Ay equals 140 pounds, okay. Now our next support reaction, since this force right here from the beginning has an x and y component, and we have a pin, so we can utilize our equilibrium equation, some of the force in the x direction, to solve that. Okay, so some of the force in the x direction equals 0. We have Ax because a negative Ax is pointing in that direction. Okay, and then plus this component right here, this 500 times 3/5, just 300. Okay, and that's how you get your Ax. Solve for Ax, you get this. Now to check to see whether you are in line or not, so for some of the forces in the y direction, you can use that as a means to check. So your Ay, because your Ay is pointing in the upward direction, is positive. Your 500 times 4/5 is pointing down, and your By is pointing up. Okay, so when you do the math, you get 0. Okay, 0 equals 0. Okay, now had you made a mistake, like I made a mistake earlier in this section right here, and I did not multiply that 5, let's say that was what, 400, right? So By equals 400, right? So let's say we do that. So now we use some of the forces in the y direction equals 0. So this is going to be 400. I got 400, right? Plus the 500 times 4/5. So that was that is minus 400. plus 260 from the AY equals 0. As you can see, 0 plus 260 equals 0. And here we have 260 equals 0. No. This should be 0 on both sides of the equation like this. Okay? This is how I would have found out that I did something wrong, and I had to go back to the drawing board here to try to figure it out. Okay? So I hope this helps. Thank you very much. If you have any questions, please let me know. Thank you.